Hello, AP Chemistry students. Welcome. So today is the 23rd of February, and we abruptly ended class because we couldn't have time to get one. I hope the last notes problem done. I hope you tried it out. It looks something like this. And I'm going to go ahead and do it with a marker right now, and you can check your answers, okay? Hope to see you in the morning for any office hours and before our quiz tomorrow, okay? So, here we go. This question is brilliantly challenging because there's so much to do. It's really got a whole bunch of our stoichiometry unit in one part. One thing that's not in there, and I didn't make you practice naming. I could have just given you the word aluminum chloride and hoped you figured out it was AlCl3 by looking up charges and balancing and doing it for all those compounds. So the first thing I want to do is make sure that equations are balanced. And this one is not. And so here's 3 chlorines and only 1 chlorine. So I'm going to put a big old 3 right there in red to stand out. And then I also see 3 nitrates and now 3 silvers. And so putting a 3 in front here will be important for balancing. Remember that this change, I'm going to put a little times 1, times 3, times 3, and times 1. I haven't put that in the notes yet before, but I want to point out that the 1, 3, 3, and 1 is related to the coefficients up here. All right, so now let's read the question. What are they asking for? Well, this question's asking for percent yield, right? And if you remember, percent yield is the actual yield divided by the theoretical yield. And the BCA table gives us an ideal world theoretical yield. And so it says that we're going to get 111 grams of silver chloride. So this is the box that we need to fill in with the theoretical yield. We know that the actual yield is going to be 11.11 grams, and whatever numbers here will go down as our theoretical yield so we can get the percentage. Okay. Now how do we do this table? Well, in this table here we have 2 pieces of starting information, and both of those can be changed into moles to put into the before, and then we got to figure out what's going to run out first. Okay. So how do we take this first piece of information to get to moles? Well, let me do that on another sheet of paper here. So I'm going to change this to 0.2 liters and multiply it by the molarity. So 0.2, I can put my calculator here so you can see it. 0.2 times 0.15 equals 0.03 moles of AlCl3. Okay? And now I'm going to do the same thing, but with the second piece of information. I know 550 milliliters, if I count the staircase 3-step, that's this many liters, times 0.25 molarity. I probably should have put an M for molarity here. So 0.55 times 0.25 equals 0.1375 moles of AgNO3. So I'm going to transpose these numbers into our before column, 0.03. I'm not going to label moles because we know that it always is going to stand for moles. By the way, this reaction has nothing to do with silver nitrate, so I'm just going to put a line, aluminum nitrate. So I'm going to put a line through here because there's no need to figure that out. All right, so now you can either take a 50-50 guess at whether you put the 0 here and fill in the BCA table because you think aluminum chloride's the limiting reagent, or if you put the 0 here thinking that the silver nitrate's the limiting reagent. Now, I see that this number is quite a bit smaller, this number, and even though I need 3 times as much of this, I don't think this number is 3 times as big as this number. In fact, I know it's not. I know that this is going to be the 0. So I'm now going to take remember, B plus C always equals A, so this must be negative 0.03. And because this change is triple this change, I know this is going to be negative 0.03. 0.09. And this will be positive 0.09 and positive 0.09. That's going to be an important number. But there is a question in there. Oh, you know what? I forgot to ask about the excess reagent. Well, let me just kind of finish this off. If I had to finish this column here, 0.1375 plus negative 0.09 equals 0.0475. A better teacher would have asked, I did kind of, how much excess reagent do we have? It's kind of in there in the second question. I forgot to put in the first question, but this would be the moles of excess right here, right? And this would be our limiting reagent, I sometimes star. Okay, so we used up all the aluminum chloride, and we have 0.075 moles of excess silver nitrate. Okay. Now, this number here is in moles, don't forget. And if we want to compare that to the actual yield, we do need to actually be in the same units. So the molar mass of this chemical is 143.3. So to convert it to grams, I will take, let me show you my calculator. I will take the 0.09 and multiply it by 143.3 to give me 12.9 grams in theory that we should get. You see, I rounded that, of course. And the final step is to finally do the actual 11.11 divided by 12.9. I got 0.86, which remember is 86% yield. Okay? There's a lot going into that problem. If you got that on your own, pat yourself on the back. You did a great job. All right. See you tomorrow for our quiz. Check out anything else you need. Email me if you got homework. Or if you have questions, I mean.